Good morning, everyone. We're very honored to and lucky to get hold of Dr. Walid Saba, who is the Senior Research Scientist at Institute for Experiential AI at Northeastern University. In his past, Walid had worked at multiple Silicon Valley-based startups such as Sorcerer, Astound, and Klengu, if I got the pronunciation correctly, as well as a few established corporations such as AT&T, Bell Labs, IBM, Cognos, and so on. Walid also spent many years in the academia, such as teaching computer science at the University of Ottawa, New Jersey Institute of Technology, University of Windsor, and American University in Beirut, and I believe, there could be a few more. Obviously, Walid has an extensive and rich career history in the tech scene and obviously in the AI space as well. Walid has authored many research papers, and in particular, he had won an award for a paper which he presented at a German AI conference, which I'm going to ask him to talk about a bit of that later. But before we begin, I'm going to pass the 5 minutes time now to Walid to do his presentation for us. Thank you. Over to you, Walid.
Thank you. And thank you for this opportunity, for inviting me. So very quickly, just to give like a background to the discussion that we're going to have after, where I stand on what's happening in AI, which is all the rage now. So let me start with saying just a while back, and by a while back, while is a fuzzy word, speaking of semantics and language, I'm talking just 2 years ago, 2.5, 3 years ago, we were afraid of having another AI winter, which I lived through the first AI winter, because chatbots were failing every day. I mean, we didn't have any chatbot that can understand, can go on in a discussion for more than a couple of minutes. We were also failing in autonomous driving, and now we have companies admitting that all we have is really basically advanced cruise control after $300 billion have been spent. So we were afraid that AI is going to get a bad word, that you guys say too much, but you don't have much to show for. And all of a sudden, we're speaking about existential threat of AI. Now we're talking about maybe AI is a danger to humanity. Something is wrong in this story, right? I mean, 2 years ago we were afraid that nobody wants to talk about AI because it's not delivering on anything, and all of a sudden, the media is saying AI is an existential threat. That's how powerful it is. That cannot happen in 2 years. Something is wrong in the story, in the narrative, in the media argument. Okay, so in my mind, this is what happened in AI. We have computational power that we never dreamed of having, clusters of computers with powerful GPUs, and we have lots of data. And if we use all this powerful computation on this massive data, we will find something, right? And what made deep learning so powerful and so popular is the ImageNet. We can now decide this is a cat, this is a dog, etc., etc. So we have massive computational power, massive data. We can apply this massive computational power to analyze this massive data, and we'll find something useful. The same thing with language. We can pretty much ingest and try to find patterns in everything that has ever been written. But that's it. That's all we have. We have computational statistics. We have advanced analytics, in my mind, as a cognitive scientist, as an AI researcher since 1985. But we definitely have nothing called understanding and reasoning. And we definitely don't, we do not have to fear a super intelligent AI. I can assure you. So all is well. Don't worry about an AI taking over humanity. But something did happen, which is what? Well, what happened is this bottom-up data-driven paradigm has produced something that's very useful, very convincing. Specifically large language models, and here I'm talking specifically, or doesn't have to be ChatGPT, but ChatGPT and similar systems like Llama and Bard. And what happened is, okay, again, same paradigm, massive, massive, massive. I mean, we're talking about 1 trillion parameters. So they tried to ingest everything that has ever been written. So basically, what happened is the bottom. You can, if you want to qualify it scientifically and technically, this is a bottom-up reverse engineering of language at scale. They basically said, "I want to see everything that has ever been written, and let's see if we can discover." Unsupervised learning, basically, if we can discover something about language from the way it was written, right? And with scale, at some point, we reached a point of scale that there was a real qualitative improvement in the capabilities, because and I had access to GPT-2, GPT-3. They were ridiculous. The scale did make a difference here. At some point, the massive amount of the size of the corpus made a difference. But the key point here is this improvement is not a question of symbolic versus sub-symbolic. In other words, it's not about neural networks are a brilliant architecture and the old methods are wrong. This is about the scale and the strategy. The strategy was correct. We should do it bottom up. And here I'm specifically talking about language. By the way, the reason it should be done bottom up, because in scientific methods, there are two methods, bottom up or top down. Top down works if you have some theories that you can start with, some general agreed on principles. When it comes to language and how we think and how we externalize thoughts in language, we have no idea. So top down will not work. That's what was smart about this. We should do it bottom up. And when I say reverse engineering of language at scale, I'm talking about scale. I mean, by the way, this is an old number. The number now is 1 trillion. So imagine that's like 3 million books. That's as much as 400 people living until they're 80 years old. That's how much they would read or listen to. So if this is the way we learn language, it will take a child 30,000 years before they can speak. Obviously, this is not how we learn language. Okay, so that's the good. That's what has been achieved. But this is where the good story ends. These large language models, despite all the hype and all the media uh, frenzy, let's call it, theoretically, we know at least some sane people that don't have a commercial interest or anything, they know that this is not the way to go. In theory, and the issues I'm going to talk about now are in theory issues. They have nothing to do with scale, like maybe if we ingest more text. No, it doesn't matter. These are in theory, quote unquote, issues. One of them is that these models, underneath them is a basic operation called similarity. They do vector embeddings, and the only operation you can do is vector similarity. But similarity is not enough. There's no notion of identity or part of or other syntactic and symbolic or semantic information. And similarity is circular, like this is similar to this is similar to this, and then this similar to this, and you get the wrong information. I don't want to get into it technically, but if you look at this paper, it really shows that what we have is a model that can approximate. By approximate, it means if we want to do simple things, like there's a term for it. It's called, in North America, they say picking the low-hanging fruits. I mean, even kids can pick up the low-hanging fruits. But what about the ones at the top? The ones at the top need more than this simple method. But it's a very powerful paper, and it refers back to very important logical and mathematical results. The other big problem in this paradigm is this paradigm is hungry for data, and if we start generating data using them, they're going to start ingesting their own data, and they're going to start believing their own lies in a way. This is another big research result. It proves that the model will collapse because you start to believe your own lie in a way, like you're basically training the model on your own generated data, so you start to believe whatever lies you spit out. There are other theoretical problems. I mean, for these models, all text is created equal. There's no facts. There's no ground truth. They don't have any way to determine what is true and what is not true. Or they will always have bias and toxic language because that's part of the data they're trained on. They're hopelessly unexplainable. I wrote about this because, and it's a function of the paradigm itself. There's no if then else. If this, then this. And so when I have a decision at the output, I can explain why I made it. These models don't work like this. They are hopelessly unexplainable. And now there's a common buzzword called hallucination, but it's not really hallucination. By the way, these models, if we say they hallucinate, we're giving them too much credit. Only intelligent agents hallucinate. These models are not even intelligent to hallucinate. What's happening is not hallucination. They get the wrong answer because the probability went this way, not this way. And again, none of these issues, none of the above issues are a function of scale. And so this is it for these models. That's the best they can do. It's not about scale or changing the model, or it's a function of the paradigm itself. And I've written a paper that shows how to test these things and show where they fail. And the challenge is not to make it's one thing to be impressed sitting home trying ChatGPT. Okay, you will be impressed, and you can use it to do many useful things. But the real test, are these intelligent systems? Do they really understand language? And the real test is to take, say, a Wikipedia page and say, can you show me? This is an informal language. English or Danish or Chinese or Hindi or whatever. Can you populate a database with the facts that are in this page? And if you test them like this, um, they are almost like flipping a coin. It's so random that. Now, if I can have just 2 more minutes, like,
Sure, no worries.
all right. So, okay. So, where do we stand? Okay. These models taught us something, but taught us something for people that are not aware of the very rich cognitive science and philosophical research and linguistic research that goes back actually to Socrates. And okay, the buzzword in this paradigm is you shall know a word by the company it keeps. And so if I do this data-driven co-occurrence analysis, I will know the meaning of words, and we create embeddings for them, etc., etc. But this is not new at all. I mean, uh, I can go back to the 1800s, but it's even older than that. It goes back to Sanskrit, and even people have always known. This is not new. These guys didn't discover anything new. This goes back to even the nature of concepts. Like, yes, to know what something is, the best way to know what the nature of what things are is to know how we talk about it in language. So the idea that we can discover the nature of concepts and thoughts and knowledge is by doing a bottom-up reverse engineering, data-driven, if you want, a process of discovering how we talk about things is the best way to do it. So there's nothing new here. And if we do that, and I just wrote a paper that was accepted, if we do that, and I've been arguing about that. I have a paper way back in 2007 that says we should do that, but we should do that symbolically, not statistical correlation and just probabilities. That will not scale to real knowledge. And if we do that the right way, if we combine the smart strategy of bottom-up reverse engineering, which in a very simple paradigm, LLMs are very simple. They're based on a very simple idea. If we do that symbolically, if we combine the power of the bottom-up strategy with symbolic and ontological and knowledge-driven methods, we can get the best of 3 words, not just 2. And that's, I think, the way forward. And that's it. So now I'm looking forward to
Thank
discuss.
you. No, that was a very exciting presentation there on language AI. I mean, just because we're working on this very big, challenging problem ourselves, and so it's very educational even for my team and I. So thank you for that, Walid. So yes, I've got many questions. So I'll start with do you see language as an intelligence, or can we go a step back and just maybe look at this question here? Do you see language as an intelligence, or simply just a communication mean or medium to express our thoughts or intelligence?
No, intelligence is much bigger than language, the short answer. Intelligence, because we do intelligent things, and we act intelligently without linguistic reference. But language is a big part of intelligence. And not cognitive, neurolinguistic and evolutionary linguistic research has shown that language came at the same time that the human species started to act intelligently. So language and thought, or language and thinking, are almost, if and only if, they came together. So the way they prove that. I mean, I'm not an anthropologist or an evolutionary biologist, but they basically trace back, or they date the spark of language with the existence of tools, and they started seeing really smart artifacts that humans started to make. So apparently language and thinking, and it's not an accident that we're the only species that can reason and use language. So obviously there's a connection between thinking and language, but I'm using thinking here in a very narrow sense, because intelligence in the bigger sense is bigger than language. I mean, a cat crossing the street is doing some reasoning.
That's right.
It's measuring the speed of the car, and it's saying, I can make it, and it's doing some physics even, like it's saying, I know how fast I can run, I know the distance, I can sense how fast the car is coming, so I think I can make it. Imagine that, right?
Yep.
So intelligence is bigger than language,
Of
but
course.
thinking
Yes.
and reasoning is very tightly connected to language.
Mm,
And when I say language, I don't mean, and that's part of my research, and that's my project. When I say language, I don't mean Danish
mm,
or Chinese, or
mm,
I mean what Jerry Fodor calls the language of thought.
mm,
That's that internal language, right?
Yep.
So yeah, language and thinking are tightly connected,
Mm,
because that's how we express thoughts. We think,
yep.
and we want to convey them. So I need to express them out in some code. The code was in some places Swahili, and then the
Yep.
code was whatever. So language and thinking are tightly related, but intelligence as a whole is much bigger, obviously.
So the key word here is related, but language itself, it's not an intelligence. The brains are, right?
The mind.
The mind
I keep, yeah, people keep referring to the brain. Obviously the brain is the
is
medium where
the
all of
mind.
this happens,
Mm,
right? But but to me, the dark matter, the secret is the
mm,
mind. It's that
mm,
abstract thing that we don't see. And
mm,
the reason I say that is, you look at a chimpanzee or a dolphin or an elephant. I mean,
mm,
the top 3 or 5 animals in terms of intelligence and IQ and memory, and I mean, take a chimpanzee. I mean, our brains are so similar, right, as a biological organ, but the gap between us and a chimpanzee in terms of thinking and reasoning is so huge that, I mean, I can bring the smartest chimpanzee into a cage by just dangling a banana. I mean,
mm,
the, so and the to see how smart they are or unsmart, uh, the chimpanzee that's behind them saw the whole thing, and I can still get them into the cage with the banana. So, uh, I mean, when we talk about cognitive abilities, we're obviously way. I mean, there's no comparison. I mean, people talk about animal intelligence. Okay, as far as animals are concerned, yes, but the gap is different. I mean, a
yep.
chimpanzee will never invent quick sort, or will never invent a recommendation system, or will never write a poem that can make people cry. Obviously, we're a unique species, right?
Yep.
So, although the biology is not that much different,
Mm,
actually.
mm. So
So
why? Sorry, go ahead.
people talk about the brain.
Mm,
It's not the brain. It's the mind,
mm,
whatever that is. I mean, we can discuss what is the mind, that
yep.
abstract thing. So to me, it's the mind, that abstract thing. That part of it was the language of thought and reasoning and
Mm.
thinking.
So why?
That's, yeah.
Right. Then why would some argue now that LLMs is the epitome of intelligence and that this advancement and development will then bring us to AGI?
No, no. To me, this is science fiction. First of all,
Mm,
I mean, first of all, LLMs. I mean, I can go online with GPT-4. I have a subscription to the latest, most
mm,
powerful. I
mm,
mean, I can make it look silly in 1 minute. I mean, look, it depends what you want to look for, and maybe we have this. Wishful thinking. I don't
mm,
know what the phrase is, or hero worship. Like we love success stories. We love to say something huge has happened. And when we see it, we live in a culture where we like superstars, and now ChatGPT is the superstar
mm,
on the scene, and so we we only look and perpetuate the big claims that are being made. None of
mm,
them is true. LLMs or large language models in general, whether it's ChatGPT or I mean, putting large language models and AGI in the same sentence
mm.
uh, is really a crime against science and logic. Actually, putting LLMs and AGI in the same paragraph or page is an insult to
Mm,
the most brilliant, penetrating minds in the history of philosophy and logic and mathematics. I mean, this is silly.
mm,
To that point, it's even silly
mm,
but unfortunately, we live in a culture where media and media hype and there's something called little knowledge is dangerous. Don't forget, and
mm.
I keep saying that too.
Right.
Since the data-driven statistical ML revolution started
Mm,
and overtook AI by a storm. I mean, we have a generation now of AI, so-called AI experts. You know, on LinkedIn, you AI slash ML slash data science slash. I mean, you're an
mm,
expert in 5 things.
mm.
I mean, Socrates said, I'm not an expert in anything, and you're an expert in five.
Five.
So you know how the brain
Mm,
works, and you
mm.
know what computation is all the theory of computation. Okay. And all they did is they took a couple of online courses, like with Coursera on TensorFlow and PyTorch. Little knowledge is dangerous, and we're
Mm,
perpetuating. And this is I wrote a post one time on I blame big tech. I mean, big
mm,
tech is the villain here. They're
mm,
perpetuating a paradigm that's not scientific at all,
mm,
and so the generation that's believing and swallowing all this misguided hype that's utterly false, not even
mm,
close to the truth,
mm,
are people that's what they were taught, right? They were
mm,
told this is AI, and we're so close of discovering how the brain works, and
mm.
so and it's unfortunate. I'm very passionate about this because I've been working in AI for at least
Yeah.
25 years. So it's
Wow.
my real passion. Before it was popular. I mean, I
Right.
so when I see these things, I say, no, please don't say that. That's
Yeah.
not true, you know.
So,
So no, there's no AGI.
mm,
LLMs and AGI are too irrelevant. I mean, it's irrelevant. It's not even relevant to AGI.
mm,
And there's proof, by the way.
mm,
Autonomous driving,
yep.
right? It's based on the same paradigm, deep learning. It
Mm,
didn't work after we spent 250, excuse me, $1 billion.
mm,
They thought if I keep training on more scenery, more situations, I will learn how to drive. No. What about reasoning?
mm,
Reasoning, the big
right.
word, thinking and reasoning. And so if it didn't work in driving, it will be a super intelligent thing. It
Mm.
didn't learn how to drive.
Right.
How could it be a dangerous AI? No,
That's right.
no,
So
no.
obvious.
This
Mm.
is science fiction.
So obviously you're taking the rule-based approach. And do you, in with that regard, do you regard linguistic discourses as rules, as rule-based,
Uh,
like the
okay. This question is,
contexts to languages?
yeah, this question is very deep. Every time I criticize the purely statistical
Mm,
ML approach, people
mm,
say, you belong to the rule-based school.
mm,
Uh, because we use the word rule-based
mm,
in the wrong sense.
mm.
Everything is rule-based.
Exactly.
Immanuel Kant said everything in nature,
Mm,
in the animate world or the inanimate world, happens according to some rule,
mm,
although we might not be aware of it. So everything is rule-based.
mm,
There's a rule, there's a procedure, there's a system, there's a description, there's a function underneath everything.
mm,
Nothing happens just if everything is random and relative and it depends and a throw of a dice and it depends, the universe would not have survived one day. I mean, so
mm,
there are rules, call them um, patterns or procedures or behind everything, of course. So when I say rules, I don't mean it in the very specific sense of rule-based systems. No, I
mm,
mean it in there's a rule. There's a there's a there's a there's a specification of how something happens
mm,
behind everything.
mm.
Yes, I definitely believe that.
And so, how then would text AI researchers rethink their strategy or their modeling right now in terms of trying to build something that has more reasoning and understanding power, basically to undertake what you call the natural language computing challenges. Yep. So if it's not large by the means of LLM and the deep learning data driven methods, um, what
Mm.
other approach or paradigm should they think about or consider?
Or
Yep.
what's missing?
Mm. Or what's
Right.
missing? Exactly.
Yeah. Yeah. I there's no escape. First of all, there are two problems in this paradigm
Mm.
as the dominant paradigm now. And ironically, just as a footnote or as a side note, um, I mean, a paradigm that I can explain in 10 minutes cannot describe cognition. It's
Mm.
that alone should tell you there's something wrong. But anyway,
Mm.
what's missing is there's no escape getting into the symbolic
Mm.
conceptual models that are in our minds. I mean, our minds don't just process patterns.
Mm.
Uh, Pattern recognition is a powerful thing we do, uh,
It's just one element.
uh, but it's one small part
Mm.
of our very complex cognitive apparatus. I mean,
Yeah.
and animals do pattern recognition.
Mm.
If you want to if our AGI goal is to be the AGI of rats, then maybe deep learning is good because uh, all lower species do pattern recognition. Actually, some animals have more powerful pattern recognition than us.
Mm.
An
Yep.
eagle, for
Yep.
example, can see from 2 miles away. You
Mm.
know, they have sharp vision that we will never reach. And some animals have hearing. That's pattern recognition is one skill, and we do it. But that's one module, and people have wrote about this. I mean, Marvin Minsky in the Society of Mind, or Jerry Fodor in the Modular Mind, where we have modules. One of them is pattern recognition. So all
Mm.
of deep learning, all this hoorah, all this hype is one module.
Mm.
That's how far we still are. All of this is one module in the big cognitive machine, right?
Mm,
Uh, so pattern recognition, and that's what these modules do. They learn, they ingest massive amounts of data, and they find very very powerful, I have to admit, very
mm,
powerful patterns. But this is a good hammer. Okay, we have a
mm,
good tool. But if I have a very nice, good hammer, I don't use it to comb my hair. Okay,
mm,
so, okay, it's pattern recognition, which is what deep learning systems do in general, neural networks. But that's not going to do, that's not going to take us there. That's just one small part.
yep, yep. And so, do you think now the challenges becomes when you start to marry between different paradigms and
Right.
approaches? Then we have to, and obviously, if you know, if we're in the tech space, you can't run away from the engineering challenges, right? So if you now, I mean, if LLMs, it's already so expensive, right? So when you start to marry, you know, more than one or two or three multiple paradigms, then what would that mean, you know, on the engineering aspect?
When you mentioned engineering, I thought you were going somewhere else. But
Mm,
okay, these are both good points.
mm,
Okay, the uh, first of all, if you need that much data,
mm,
that massive, I mean, if I have to see 20,000 cats to recognize a cat, I'm doing something wrong.
mm,
I had children. I still have children. Once you have children, you always have children. Okay.
mm,
So, and and I used to uh, sort of like observe how they learn things, and because I was doing my PhD back then, so I was like doing experiments on them without telling them.
mm,
So, yeah, a child sees one cat or one bird, and they say, "Okay, these are birds. I'm done."
mm,
So these systems are so expensive to work with because they are so blind and dumb that they need more and more and more and more to figure something simple.
mm,
Simple. So obviously that alone should tell us scientifically
mm,
that that's not the way. I
mm,
mean, I don't, I've never seen a child, like I just showed in one of my slides. If that's how we learn language, the child will have to be 25,000, 30,000 years
mm,
old before they speak. That's not how we learn. That's not how we discover things. So obviously this paradigm is not computationally plausible, is not psychologically plausible, is not cognitively plausible. I mean, so the idea that the mind, the modular mind, I'm talking the society of mind, I'm talking about, where pattern recognition is one module,
mm,
should not have this overhead if
mm.
it's done right.
Yeah.
Uh, but if we believe, by the way, this is why I think this paradigm is being pushed so hard
Mm,
now. My statement might sound political. It's not political, but because this paradigm is based on big data.
yep.
And who owns big data? The tech giants.
Mm,
This paradigm requires big compute. Who
yep.
has the big compute? The
They.
tech giants.
Mm,
So it suits them well,
yep.
even if it's not the right paradigm. So
Mm,
this is not the vision I see. The vision I see is a society of modules that
mm,
Marvin Minsky has a brilliant observation. He says, intelligence will emerge. It's sort of like an emergence
mm,
from modules that none of them is smart on its own.
mm,
Each is so specific. I mean, we have a color module. We have a module doesn't know anything except I'm a color expert.
mm,
I can tell you everything about colors. I'm a shape expert. You give me any shape, I can analyze shapes. we have a pattern recognition module like a neural network that sees a blob of things and says, I recognize this pattern. We have a module that does deductive logic. We have a module that's good in language. We have a module that, and the modularity of mind has been proven neurologically even.
Mm.
We know I can have a defect in, I can be dyslexic, but I can be a chess grandmaster, but
Mm.
I have a defect in one module. So the modularity of mind, and it's interesting. It there's a parallel between that and software engineering. Like,
Mm.
you have
And hardware.
and hardware,
Yeah,
because hardware were the masters of modularity. I
correct.
have right.
Mm.
So the mind seems to be this machine with specific modules. Like now people talk of neurosymbolic or hybrid. That's the wrong word. The wrong word is modular AI, not hybrid AI. None of these modules is hybrid on its own. Like
Mm.
you can't be, I can do this and I can do this if you want, and I can do pattern recognition. I can,
Mm. Mm.
no, I have a module that is expert at sorting. You give me a collection of anything, I'm an expert at ordering things and sorting them out, right?
Mm.
That's it.
Mm.
Now, intelligence comes from the controller, the
Mm.
mind, that is
Mhm.
saying, I got this situation, you do this, you do this, you do this, and you guys tell me what you found out, and I'll reach it.
Mm.
So that is the AI that I see and
Mm.
that I'm working on.
Mm.
A modular AI where you have specialized modules. Well, one of them is a neural network that's good at pattern recognition, but that's just one module
Module.
in a very
Very
complex
complex.
society of
Mm.
mind. I mean, the mind
Mm.
is a society of modules working together, right?
Mm.
So
So
when I
it.
hear
Mm.
people say AGI because of stochastic gradient descent and backpropagation, that's the whole mind. Are
Yeah.
you like, I mean, you,
Yeah.
if you read one philosophy book or one, okay, it doesn't have to be philosophy. But,
Mm.
okay, what are you talking about, right? So
Mm. Yeah.
anyway, I'm too passionate. Maybe I keep going
No, no,
on, but
no. So I mean, obviously, from what we you have shared and what we have discussed, there's still lots to do, obviously, on the
oh,
research side, technologically,
oh,
engineering, and also the resources to power, these models or this tech, infrastructure and whatnot. So can you then, shed light on this, on the simple answer? Do you think right now I mean, this is the super obvious question, but I'm just saying this for the audience. Should we now be concern about the whole, yeah, yeah, existential threat that AGI will bring to us and to humanity?
no.
Mm.
Uh, and not because we don't have the AI that is being hyped and
Mm.
talked about. No, even if we have super intelligent AI, we should never fear. Uh,
Mm.
and there's a logical proof for that. I mean, any talk of existential threat is very misguided, and we humans are good in imagination and sci-fi, science fiction. For an entity to be dangerous, right?
Mm.
I mean, if we're talking about an AI that will harm humanity,
Mm.
that's the theory. Uh, if I want to do any harm, if any entity wants to do any harm, it has to devise a plan, right?
Mm.
And in executing your plan, you have to have a way of knowing, am I getting closer to the goal or not? And in doing so, you have to say, these things were not true before I did this action. Are they now true?
Mm.
So basically, no entity, n- nobody and nothing, no entity can be dangerous if it cannot evaluate what's true in the word it's in.
Yeah. Yeah.
And AI systems will never get this ability. They will never know
Mm,
what's true outside of their environment.
mm,
They are told and
mm,
programmed. We
mm,
feed, even if they learn from
mm.
data, we feed
We-
them the data.
mm,
So you can, uh, I need Bertrand Russell here or Gottlob
mm,
Frege, like to have a formal proof,
mm,
but intuitively, you cannot be dangerous unless you can devise a plan
mm,
with a goal. And that means you know how to evaluate the state of affairs in the world you live in to know
mm,
that your plan is proceeding.
mm,
These are capabilities that machines can never have,
mm.
can never, not like
It's not even a
theoretic.
question of when.
No, never,
Mm,
never. Because uh, unless we reach a point where machines will have all the innate intuitions and innate knowledge, because we are born not blank slate.
mm, mm,
This gets us into like
mm.
we,
Genetic programming.
we yes,
Mm,
we over millennia we have in our genetics and
mm,
in our DNA and in our we have encoded
mm,
a lot of knowledge about how the world works.
mm,
It's not an accident that a child, when they are born,
mm,
but before going to human species,
mm.
animals, a calf, a newborn cow, you can see videos on YouTube
Yep.
or anywhere, or if you lived near a farm, you can see it physically. 10 minutes after it's born, it starts
No, it's just
standing
stand.
up and walking, and it
Mm,
starts going around and grazing and eating on its own.
mm,
Where did that knowledge come from? Who? It's
mm,
encoded. A
mm,
child, when they are born, they don't choke themselves. They know physically, I shouldn't do this. There's a lot of knowledge encoded
mm,
that was otherwise we wouldn't have survived.
mm,
It's encoded. All of that, we think it's nothing. That is the thing. And
the
the
thing.
rest is extra. The,
Mm,
the rest is extra, actually.
yep. Yep.
Uh, so a machine will never have that
Mm,
because it didn't spend 2 million years
mm,
evolving
mm,
and figuring out the laws of nature
mm,
encoded in it. That if I throw something, it will not go up, it will go down.
mm,
Machines don't have the laws of nature encoded in them like we
mm,
did through
mm.
evolution.
Yep.
So now someone might tell me, what about if we keep training machines for another 2 million years? Okay, maybe,
Mm,
but that's like basically it's science fiction,
mm,
right?
mm, mm,
And the reason is not that they're not intelligent enough.
mm,
And I was just telling a friend actually last week we were having a chat, and I said, we should go back to the first phrase we use, not
mm,
artificial intelligence, machine intelligence.
mm, mm.
We will
Yep.
have intelligence, but it's a different kind of intelligence. We will
Yeah.
never have a human intelligence, right?
It makes more sense.
And
Mm,
yes, and they used to use this term in the 50s, at the beginning of the field,
mm,
machine intelligence. It is intelligence, but it's a different kind of intelligence.
mm, mm.
So the idea that you will have a silicon at some point waking up at night and saying, I'm going to kill all of humanity, this is science fiction
Yeah.
because machines don't even have intentions.
Mm,
And intentions require consciousness and reflection
mm,
and a process of decision making. I decided to devise a plan. Like all of that is science fiction. It's
mm.
And I wrote an article about that. Like, stop saying, like,
Right.
now, can they be dangerous in the sense that a gun can be dangerous? Yes, I
Misuse.
can
Yeah.
misuse anything.
Mm.
And so a rock can be dangerous because some people use a rock to kill
Mm.
people. A rock
Yeah.
can crush the head of some.
Yeah,
So,
it depends on how you
and
use
we
it, right? Yeah, a kitchen knife,
exactly
it's useful to cut poultry meat, but you can kill too.
right, right.
Mm.
And I can't live without a knife, but I
Mm.
will never use it to,
Mm.
but so it can be dangerous if we rely on it too much and
Mm.
believe that it's super intelligent.
Mm.
ChatGPT can be dangerous
Yeah.
because actually there was a case that some guy
Mm.
took the advice of ChatGPT and committed suicide.
Mm. Mm.
So if we're gullible and we're silly and yeah, it can be dangerous because we
Mm.
misused it, not because it
That's
can
right.
again wake up at night and decide to make us extinct.
Yep.
That talk is science fiction,
Mm.
not based on any logic, actually.
Thank you, Walid. But unfortunately, we don't have much time, but we still have a time for a few questions. And indeed, we
Sure,
do have two here, Walid, for you.
sure.
Since you just touched on GPTs, this question is related to that. How can AI models like GPT-3 or 4 be integrated into human workflows for maximum productivity?
They can definitely be. This is the right way to think about this technology.
Mm.
We can definitely use the power of these tools now before
Mm.
we get to real language understanding, real
Mm.
reasoning.
Mm.
They are powerful tools.
Mm.
Actually, if we, and this is going to be, even from a business point of view, if
Mm.
you are like an entrepreneur, I would say think about smart ways of exploiting the power of these things, like
Mm.
know what they're good at. And with complementary technology, you can make amazing solutions to real business problems.
Mm.
Uh, for example, I mean, you can use LLMs, GPT-3 or GPT-4 or Llama or any
Mm.
large language model. You can use their linguistic power. They obviously discovered a lot about language,
Mm.
right? So use their conversational power, but they don't know anything about anything, facts
Mm.
and reasoning. So if you can build tools, like for example, I'm working on a project now that will use LLMs with complementary technologies that
Mm.
are knowledge graphs, ontologies,
Mm.
semantic processing
Yep.
to extract knowledge graphs and entities and relations from raw data. You exploit their power to uh, short answer. There are lots of ways.
Yep.
Think
Yep.
this way. Think about what they're powerful at.
Mm.
They're powerful at understanding a question because they saw millions and
Millions.
billions yes,
Mm.
and they're good at producing an answer in a very coherent way.
Mm. Mm. Mm.
So on the input and output, they're really good. In the
So,
middle, they know
mm.
they know nothing about nothing. Now, if you
Mm.
build complementary tools
Mm.
in the pipeline in the beginning and at the output
Mm.
to synthesize what they said and analyze it, or give them the right input because
Mm.
you did some smart thing before. One technique that's now very powerful is RAG,
Mm.
retrieval augmented generation.
Mm.
So
Mm.
they don't know, let's say, your domain. It could be medical. Like we're working on a project where can I summarize electronic health records? They're
Mm.
massive notes taken. Like, okay, the large language model can take questions, but if you ask them about this domain, they don't know anything, and the answer will be gibberish. Like, okay, but if I give
Mm.
them a good context, I say, answer this question, but take this information into consideration. Wow, they give me the right answer.
Mm.
So my answer will be use them, uh, use their strength,
Mm.
but don't think they have any solution for you. But
Mm.
it's a powerful tool.
Mm.
You have to build complementary. technology at the end
Mm.
and at the beginning in the pipeline, right? And there
Mm.
are many, many smart ideas. I can get into some of the ideas I'm
Right.
working.
So
So use
should
them,
Mhm.
use them. They are powerful tools. Yes.
Do you think that LLMs should also be more used in a more narrowed way with structured data and in fields where, let's say, even a minor inaccuracy is absorbable, like they could absorb the, like let's say, like if you're trying to re-summarize a sales email, a template,
Right.
right,
Yeah.
for instance, and if you make some inaccuracy in your rephrasing of your sentences, it's not going to cost you your business. But if you
It's
apply it on finance or healthcare or legal, one missing word will be misinterpreted because
oh, yeah.
it doesn't understand, it doesn't. So the whole NLU and the NLG part is still very immature
Yeah.
in that sense. So how would people think about that, like when they're using
They,
LLMs?
they should definitely take that seriously into consideration. So
Mm,
if I want to summarize, okay, I'm a lawyer and I got a 30-page report.
mm,
Uh, just give me the headline. So I put it to ChatGPT and it gives me a good summary.
mm,
Brilliant. Hey, it missed a couple of things.
mm,
It's okay. No harm done.
mm,
Or if I am a marketing agency and I want some ideas,
mm,
and actually I tested them on that, they're really good
mm,
because they memorized everything that has ever been written. So
mm,
they'll give you ideas that were written by some guy in Denmark. Like
mm,
they memorized everything that has ever been written, right? So
mm,
in that domain, I'm a marketing person, and I want to write a nice blog on my product. Okay. So I give a description. I say, give me a a good paragraph or two to market my product. They give you ideas. There are so many use cases where no harm is done
mm,
if they make a foul or
mm,
two or even five fouls. It's
mm,
okay.
mm.
It's
Right.
now, but I will never use it to query my database in a bank. No,
Mm,
no,
yeah.
no, no,
Yeah.
because there are places where are 0 degrees of freedom,
Yeah.
right?
Yeah.
We call them 0 degrees. I mean, here you have to be accurate. You can't tell me John deposited $2,000, but when I check, it's 200. I mean,
Mm,
the
yeah.
zero here, man. So there are places where I will not rely on them.
Mm,
There are places in the middle,
mm,
which I mentioned one of them, like I want to extract information from electronic health records.
mm.
If they're 90% accurate, they're still saving a physician 10 hours
Yep.
because
That's right.
instead of looking at 50 pages of the patient record over 5 years,
Mm,
they're looking at a couple of pages that summarize the whole thing.
mm,
So so there are places where complete flexibility, I can live with all kinds of fuzziness and
mm.
approximations. There are
Right.
places where it's zero. So
Mm,
there's I'll accept any unreliability. There are places
mm,
where I accept zero unreliability. And there are domains where I can live with a good thing with, like I said, complementary tools that make them work better.
mm.
So we have to know where to, yeah.
Yep. Thank you. One last question, Walid. Can AI be multilingual? Will the different languages conflict with each other and affect the AI, the text AI?
Good question. That's the passion of my life since 20 years ago, including in my sleep. That's my ongoing project,
Right.
besides the stuff I have to do to make a living.
Mm,
And now my work is starting to get some attention, which is true language understanding. Actually, you don't have a system that truly understands language
mm,
unless it's language agnostic and it can handle all languages.
mm,
Because underneath all our languages is the same language. The language of thought is the same. The output is different, and we express things in different ways. So yes, AI can be, and if it is not multilingual, it's not AI. Actually, if you don't have a multilingual AI that doesn't think in a specific language but can handle any language, and I don't mean translation here. I mean it it can take input in any language and it understands it the same, then it's not AI. So it has to be multilingual, because human intelligence is multilingual or language agnostic. We think the same way. I mean,
Yep.
whether you're in China or India or Denmark or Sweden, there are things, and things have properties. And so the conceptual system we have is the same, and
Yep.
it's not language dependent.
Agree. Thank you, Walid. That was very insightful and very refreshing to, even for myself. I'm still learning, and I've been a fan of your work. I've been listening to your podcasts and skimmed through some of your research papers, and a shout out to, I actually first noticed you on MLST, shout out to them, machine learning.
I like those
Street
guys.
talks. Yeah, I mean, for those who are tackling AI research, should go check them out on the YouTube and Spotify.
And I like them, and we became friends, although it's been a while. Because they don't like the the hype, and they go into the science.
That's right.
So I like those guys, and they're very smart themselves, very brilliant.
So yeah, we thank you very much. Well, then for a shout out to the audience, if let's say anyone would like to get hold of you, to collaborate on research or whatsoever, where can they
By
find you?
all means. Please give them my email.
Okay.
I
Or just approach you from LinkedIn. Will that work?
I mean, I gave you two emails,
Yep.
personal and work. I have
Yep.
no problem if they
Okay.
want to follow up on something,
Yep.
or
So
they
just
like to, and even if they like to collaborate on anything,
okay.
sure.
So for those of you who would like to get in touch with Dr. Walid Saba, just reach out to us, and we'll pass you his email, and then all right, thank you.
Or Walid without doctor.
Yep. Oh, Walid without doctor. All right, thank you, Walid. Have a good night and good evening over on your end, and thank you very much again for sharing your precious time with us and your insights. And we'll speak to you again soon.
Thank you.
Thank you.